Hello viewers, welcome to my channel, Queen Happiness Knowledge Quest. Enjoy your learning experience. Today's topic of discussion is basic chemistry of carbohydrates. The presentation objectives are to define carbohydrates, classify carbohydrates, and list the properties and functions of carbohydrates. So now what are carbohydrates? Carbohydrates are called saccharides, and they are the most abundant class of organic compounds that are found in living organisms. They originate as products of photosynthesis, and the formula of many carbohydrates can be written as carbon hydrates, CnH2ON. Hence, they are called as carbohydrates. The carbohydrates are polyhydroxy alcohols which act as major source of metabolic energy both for plants and for animals that depends on plants for food. A key point to be taken about carbohydrates is they are energy-giving organic molecule made of carbon, hydrogen, and oxygen. About 60% of our food should come from carbohydrates, and they are the major source of energy from our diet. They are composed of three elements, carbon, hydrogen, and oxygen, and they are produced by photosynthesis in plants. This picture depicts how plants produce carbohydrates using sunlight as major source of energy. The carbohydrates that are produced is utilized by the organism through a process called respiration to release back carbon dioxide and water. This equation that is shown here shows that starch or glucose is produced through a process called photosynthesis by combining carbon dioxide and water in the presence of energy, that is sunlight. The equation present here shows how carbon dioxide and water in the presence of sunlight is converted into glucose and oxygen through a process called photosynthesis, and back to carbon dioxide and water when we respire. Most abundant organic compound in the plant world, and 3/4 of the weight of plants are carbohydrates. Coming to the stereochemistry of carbohydrates, many carbohydrates exist as enantiomers. That is, they are mirror images. A chiral object cannot be superimposed on its mirror image, and a chiral carbon is one that has 4 different groups attached to it. Example as shown in this figure, we have a carbon atom attached to an aldehyde group, hydrogen group, OH group, and CH2OH group. A pair of stereoisomers designated as D and L at the start of their name indicates the stereochemistry. These images cannot be overlapped. The compounds can have more than one chiral carbon, and accordingly we have the number of stereoisomers. When you have 2 chiral carbons, we get 4 stereoisomers, and we have 4 chiral carbon, we have 16 stereoisomers. So the common formula for finding the number of stereoisomers is 2 power n, where n stands for the total number of chiral carbon. Coming to the Fisher projections. Fisher projections of carbohydrates have the CO group at the top, and it is a way that we project the molecule when we view from behind the plane. The hydroxyl group on the chiral carbon is farthest from the CO group, which determines whether the carbohydrate is D form, that is, the alcohol group is on the right, or L form, that is, alcohol group in the left. The key point is the Fisher projection depicts 3-dimensional shapes of chiral molecules with a chiral carbon atom represented by intersection of 2 lines, that's shown in this picture. Coming to the classification of carbohydrates, we have various criteria that is used for classifying them. The first one is based on the complexity, which is classified as simple carbohydrates and complex carbohydrates. Monohydrates are called as simple carbohydrates, and complex carbohydrates include your disaccharides, oligosaccharides, and polysaccharides. The carbohydrates are also classified based on the size or number of carbons as tetrose, pentose, hexose, and heptose as C4, C5, C6, and C7 sugars. Based on the functional group, the carbohydrates are classified as aldose sugar, which has aldehyde functional group or an acetyl equivalent, and a ketose group which are having ketose group or acetyl equivalent. They are classified based on the reactivity as reducing or non-reducing sugars. The sugars that can oxidize Tollens reagent or Benedict's or Fenning's reagent, they are called as reducing sugar, and the ones that cannot oxidize, these are called as non-reducing sugars. Classification of sugars is also based on the total number of sugar molecules that they carry. Monosaccharides are simple sugars which carry a single unit of carbohydrate. Examples are glucose, fructose, and galactose. Oligosaccharides contain several monosaccharide residues which are linked by glycosidic linkage. When the number of monosaccharide is 2, then we call them as disaccharide, and the numbers less than 10 are called as oligosaccharides. Examples for this class of carbohydrates is sucrose, lactose, maltose, raffinose, etc. The last group is polysaccharide, which is a complex molecule. And many monosaccharides are joined by glycosidic linkages. Examples are starch, glycogen, fiber, and gums. This slide shows the outline classification of carbohydrates: simple carbohydrates, complex carbohydrates. Under simple carbohydrates, we have monosaccharides and disaccharides. Under complex carbohydrates, we have oligosaccharides and polysaccharides. So example for under each category are shown here. For monosaccharide, we have glucose, fructose, and galactose. Under disaccharides, we have lactose, sucrose, and maltose. Under oligosaccharides, we have example of raffinose and stachyose. Under polysaccharides, we have glycogen, starch, and dietary fiber. So this picture shows an overall classification of carbohydrate. Under this polysaccharides, we could see that they are of different types, which is of both plant origin and animal origin. And under fibers, we have pectin, glucan, gum, cellulose, hemicellulose, etc. There are few key terms relating to carbohydrates. Now let us see them. First is aglycone. This is a non-sugar part of glycoside, usually an alcohol, phenol, or amine. Aldoses refers to monosaccharide that contain aldehyde function. And aldopentose refers to a 5-carbon sugar with an aldehyde or cyclic hemiacetyl functional group. Aldohexose is a 6-carbon sugar with an aldehyde group or cyclic hemiacetyl group. Ketoses refers to monosaccharides that contain keto function. And furanose refers to 5-member cyclic sugar which form furan. Pyranose refers to 6-member cyclic sugar which is from pyran ring. Septanose refers to 7-member cyclic sugar. Glycosines refers to intramolecular glycoside, which is formed by anhydrous sugars by releasing water molecule from a pair of hydroxyl group. The glycosines are strictly intramolecular glycosides. Alpha or beta glucoside refers to acetyl derived from cyclic hemiacetyl from alpha or beta glucoside glucose. And alpha or beta glycoside refers to a general acetyl derivative of any sugar. Monomers are sugar isomers that differ only in the configuration of the hemiacetyl carbon atom. They are designated as alpha or beta. Epimers are sugars that differ only in configuration at first carbon, and mutation refers to a change in the optical rotation when a fresh solution stands. After knowing the basic terms about carbohydrates, now let us see about the physical properties of carbohydrates. The first property is solubility. So unmodified monosaccharides, oligosaccharides, and polysaccharides are generally readily soluble in aqueous solvents, while the highly crystalline polysaccharides like cellulose, gelling polymers such as agarose, highly branched or cross-linked polymers such as starch are often insoluble in aqueous solvents. The second property is relating to viscosity and surface activity. The polysaccharides are most viscous natural products, and this viscosity increases with the increase in chain length or molecular weight. This makes them useful in the food industry as thickeners are gelation agent and high viscosity agents. The polysaccharides have affinity for high oil-water interface, which gives them great value as emulsifiers. In biological systems, we have a list of polysaccharides that can act as emulsifiers and other components. Examples are hyaluronic acid, which is a major component of synovial fluid and vitreous humor, making it appropriate for use of this because of its highly viscous nature. The third feature is crystallinity. They have a wide range of crystallinity except for sucrose and cellulose. Other carbohydrates are difficult to crystallize. There is a difficulty in crystallizing carbohydrates, which results from their conformational flexibility as well as the presence of multiple structural forms of reducing sugars. Next is hygroscopicity, that is the ability to gain water from the atmosphere. Many of them are hygroscopic, about 2 to 10%. Even after extensive efforts of drying, they have water molecules in them. The alginic acid, a polysaccharide found in seaweeds, function as an anti-desiccating agent that maintains the viability of seaweed washed ashore on hot beaches. Coming to the stability, the carbohydrates are fairly stable molecules and the reducing sugars contains aldehyde or hemiacetal functional group and are therefore sensitive to oxidation. Polysaccharide, which is alginate in a warm aqueous solution, can form either a helix or a gel on cooling and in the presence of calcium. Coming to the optical properties of carbohydrates, they absorb very little light in the ultraviolet and visible spectral regions. They have multiple chiral centers of carbohydrates, which makes them optically active. Circular dichorism, optical rotatory dispersion, and infrared spectroscopy have been used to study the conformations of carbohydrates. Now let's see about the chemical properties of carbohydrates. The first property is hydrolysis or solvolysis. The glycosidic linkages that occurs in branching sugars can be acid hydrolyzed using mild hydrolysis condition. And oligosaccharides and polysaccharides can be solvolyzed in methanolic hydrogen chloride to afford methyl glycoside products. Coming to the oxidation reduction properties of carbohydrates. Carbohydrates are highly oxidized molecules. Except for specific functional groups, they are relatively insensitive to oxidation. Aldehyde group present in reducing sugars can be oxidized to an aldonic acid under relatively mild conditions. The stronger oxidants are required to oxidize primary hydroxy groups to carboxylic acids, and secondary hydroxy groups require even stronger reagents such as formic acid to modify them. Coming to the functional groups and chelation and complexation properties, they possess a number of different functional groups in addition to the commonly found aldehydes, primary and secondary hydroxy groups. The free amino group in amino sugars can be acetylated, acylated, sulfonated, or phosphorylated. The carboxy sugars can be esterified or amidated. The hydroxy groups substituted as O-acyl, O-sulfo, or O-phosphoesters are typically hydrolyzed under basic conditions. The glycans and their derivatives display affinities towards metal ions. The divalent cation calcium is used for ionically cross-linking acidic polysaccharides such as alginate, which is a polycarboxylate, and carrageenan polysulfate to form a gel. Copper is readily chelated to polysulfated polysaccharides such as heparin, dermatan sulfate, thus affecting their solubility and their detection. With reference to the biological properties of carbohydrates, they are best energy storage systems. Highly branched glucose-based polysaccharides such as starch, glycogen serve as efficient means of stored energy which is used for rapid utilization. Through enzymatic hydrolysis of these molecules to monosaccharide glucose, we can maintain energy balance of the cell function. It also helps in structural role. Linear polysaccharides that contain highly ordered secondary structures are important in making up the structural components in both plants and animal tissues. Cellulose and pectins are seen in plants. Glycosaminoglycan chains or proteoglycan molecules is a major component of extracellular matrix in the case of animals. The carbohydrates also play a role in cell-cell interaction and cell-like communication process. The glycoconjugates are covalently linked to the proteins, that is glycoproteins, and proteoglycans are lipids, which are called as glycolipids, are localized to the cell surface on the extracellular spaces, and so they help in communication. They also enable cell-to-cell interaction and cellular communication in the form of specific molecules like lectins and receptors. Sweetness receptor is in the taste buds, which helps you to feel the taste of different sugars that you consume. Coming to the functions of carbohydrates, they provide energy for most obvious functions of our body, such as moving, thinking, or any other activity, and also for background functions that most of the time we do not even notice. The body utilizes glucose directly as energy source in the case of muscle, brain, and other cells. They play an important role in structure function of our cells, tissues, and organs. The starches and sugars are the main energy providing carbohydrates and supply 4 kilocalories per gram. They are all polyols, which provide 2.4 kilocalories or 10 kilojoules. Under this, your erythritol is not digested at all and thus gives 0 calories. Dietary fiber that we consume gives about 2 kilocalories or 8 kilojoules. The stored form of energy is glycogen. Spare proteins and fats are other functions that a carbohydrate can do. They build macromolecules or form intermediates in the biosynthesis of fats and proteins. They also form the part of cell wall, cell membrane, and other cellular components like your nucleic acid, DNA, and RNA. They provide fiber for easy digestion and excretion that helps in preventing constipation. They also add flavor and sweetness. They are linked to many proteins and lipids, and they are linked to important cell-cell communication and interactions that occurs between cells and other elements in cellular environments. In animals, they are important constituent connective tissues. As a summary, the takeaways that we have from this presentations are: carbohydrates are organic molecules. Carbohydrates are energy givers. Carbohydrates are classified based on various criteria. Carbohydrates have unique physical, chemical, and biological properties. Carbohydrates are important biological molecules and they play an important biological roles. Carbohydrates find uses in various fields. Thank you.